We are now moving on to electricity. However, because many of the equations that are important in electricity and which you must memorize are very similar to the equations for gravitation, we're going to look at the equations side by side for two reasons. One, it will be more easy for you to memorize the two sets of equations, and secondly, you'll be able to see parallels between the two sets of equations. So first, electricity. F is equal to QE, one of the most fundamental equations. That is, the force in an electric field is equal to Q, the point charge, times E, the electric field. The relevant equation in gravitation is F is equal to mg. That is to say that F, the force in a gravitation field, is equal to m, the mass in the field, times g, the acceleration due to gravity. So you can see the similarity of these equations. Now, the most fundamental equations in motion comes from Newton's second law. And Newton's second law is that force is equal to ma, which is force is equal to mass times acceleration. So let's look at a derivation of that law. That is to say that acceleration is equal to force over m. And from the first equation, we see that F is equal to QE. So therefore, acceleration is equal to QE over m. In other words, the acceleration in an electric field is equal to the force over mass, that's Newton's second law, which is equal to QE over m. So this provides you the acceleration in an electric field. The acceleration in a gravitation field, we do the same thing. A is equal to F over m, which is equal to mg over m. Well, the m's cancel, and we just end up with g. In other words, we get the trivial result. And that is that when we have the acceleration in a gravitational field, that is simply equal to the acceleration due to gravity.